Hello everyone, this is Dr. Abdul Pasha. So the course is Power System Operation and Control. Here I'm going to explain about need for load frequency control. So we discussed some key points in load frequency control. So here it will describes what is the necessity of controlling the load frequency and what are some objectives assigned with it that we will suppose to discuss here. So need for load frequency control. Load frequency control is necessary to maintain a power balance. It maintains the power in balanced condition in between the interconnected areas and to regulate the flow of power in a power system. So load frequency control is important because of the following some reasons. So the first reason is voltage and frequency regulations. So the voltage and frequency regulations are maintained like this. So these are the most important challenges in electrical power systems. This is due to the load variations, and power balance can be achieved in the power system network by electric power that should not be stored usually. So in large quantities this is made difficult. Only battery operated can store. So production must equal to the consumption at all the times. Coming to the non-linearity case, so modern power systems are large scale. So they are non-linear, non-autonomous, dynamic systems. So load frequencies are certain objectives. They may include like generating and delivering power economically and reliably. So they are supposed to maintaining the voltage and the frequency within the suitable limits. So load frequency control loops controls the active and reactive power cases. That means as well as the automatic voltage regulator, they may changes in real power mainly affects the system frequency. That means while reactive power is less sensitive to the changes in frequency, the load frequency control will take over the thing. So the objectives of the load frequency control are here to maintain the power balance. That means that is in between the interconnected areas and to control the power flow in the tie line cases. So these are the end lines where we supposed to maintain the power balance. So electric power cannot be stocked in large quantity. So that's why it is production must be equal to the consumption at each time. So coming to the introduction to the load frequency control of thermal power plants, when we introduce load frequency operation in large thermal power system network, then it associates with various parameters. So that we supposed to discuss here. So now we have seen that what a thermal power plant, so it is and what processes are going to be taken place inside it. So the next level we shall learn the method adopted to control the intake of the steam in order to control the terminal voltage that should be generated by the generator itself. That means here the load frequency control operation in thermal power system is most important while it is generating huge amounts of power to the entire power system network, means the generated power will associated with thermal power system network. So the electric power generated by the electric generator is transmitted through the transmission lines. That means, and it is supplied to various loads, and the generators are normally used will be known as alternators or synchronous generators. Alternators or synchronous generators. So usually a synchronous generator is a doubly excited machine. That means where it has two sets of windings. So one which is wound on the rotor and is excited with the DC source. One is wound on the rotor and another is excited with the simple DC source. So the second, that is wound on the stator case, that should be where from the output electric power is going to be tapped here. So likewise, two multi operations are going to be taken place for the particular synchronous generator. So here the power generated is then transmitted to the load centers. So these load centers constitutes houses, industries, hospitals, and like that it may take so many examples. So one might know that these load centers have their respective demands in nature. That means, but these demands vary with the time and never remains constant. That means the load connected to a power system network is a variable parameter. So we state that the changes in load demands leads to the changes in input. This is most important case. Whenever there is a change in load demands in terms, then leads to the changes in the input power case. So one must know that when the input to these load centers changes in it, then in turn indicates that the power generated by the generator must change. So from the fundamental equations of the machine, the generated power is 2 pi n t by 60. Here the Pg indicates the generated power. So n indicating the rotor speed and t is the torque developed inside the machine. So here it is observed that the power generated is directly proportional to the rotor speed usually. That means this is happened to the generator in RPM case. Now we also know that the rotor speed is also directly proportional to the frequency term. That means from the relation of n equals to 120 f by p, where n is the speed and f is the frequency here and p are the number of poles of the given machine, then as a result, when the speed increases, when speed is going to be increases, then frequency also increases. Speed increases means frequency also going to be increases. So, but this is not acceptable usually. Why? Because we are maintaining constant frequency, that is about 50 Hz. In our India, the frequency, operating frequency range is about 50 Hz. But the developed countries like US, UK, they're supposed to operate the frequency ranges till 60 Hz range. So here in the power plant, we use synchronous generator to produce electric power. So such machines obtain a stable mode of operation. That means at its synchronous speed, this is going to be taken place. Thus, an increase in speed may result in changes in rotating characteristics. That means which may leads to the damage case. So all power loads in the bus are designed at a rated frequency, that is in India 50 Hz, that we already discussed now. So thus a change in the frequency may leads to the damage to the loads. So for instance, transformers flux generated must be remains constant. So here when flux is proportional to the V by F ratio, where phi is the amount of flux generated, V is the terminal voltage, F is the frequency. Then if the frequency is going to be decrease in manner, then it leads to the increase in the flux case. The decrease in flux may leads to the increase in the flux case, that may result in saturation of the core. So thus changes in frequency leads to a lot of problems to the network case. So we adopt the method called the load frequency control. So to maintain the frequency of the system, that should be taken place at the rated value case. So this must be noted that we should operate at the rated value case. It should not make beyond it and should not make exceeding it and minimal that value. So we should maintain the constant frequency. So coming to here, that load frequency control is treating it as a critical component. That means this may be treated as one of the complex component in the power system network operation. So which may ensures results to the stability and reliability of the electric power grids. So here the primary objective of the load frequency control is to maintain the system frequency, that is to be at a desired level, which may happens about 50 Hz or 60 Hz range. So this may manage the active power generation to the balance the load demand scale. So here's the breakdown of the need for the load frequency control operation. So based on the load requirements, breakdown of the need for load frequency control is going to be takes place. So usually the operating frequencies are 50 Hz or 60 Hz, but in our India we are treating 50 Hz based on the power generation components. So we may treat it as 50 Hz. This is the main primary objective of the load frequency, to maintain the frequency at the desired level. So here one of the parameters that should influence mostly for the load frequency control case, that is called frequency stability. So the frequency of your power system is directly related to the balance between generation and load. So the frequency of power system is directly relating to the balance between the generation and the load case. So when the load on the system increases, load is going to be increases, then what happens means, so this may happens without a corresponding increase in generation. So the frequency may goes to drops, that means it may decreases. So conversely, what happens means, when the load decreases, or it may be generation increases, then frequency may goes to hikes. That means frequency is going to be increasing back. So here the deviations from the nominal frequency may leads to the serious problems. What happens means, such malfunctioning of electrical devices, tripping of protective relays, and even large scale blackouts are going to be expected. So here load frequency control helps to keep the frequency within the acceptable limits. So another second parameter influencing the need for load frequency control case is balance between the supply and demand. So in real time, what happens means, electric power demand is constantly fluctuating. So power generation must be adjusted here to match this load. So load frequency control ensures that the generation is dynamically adjusted in response to the load case, and it also affects by the variations in the load parameter. So keeping the system in equilibrium conditions. So without considering the load frequency control, significantly the frequency deviations could occur that may result or comprising the system stability parameters. So here interconnected power systems are taking place. So those are influencing one of the load frequency control approach. So that may be taken place as with the modern grids, with the latest development of the grid parameters. So power systems are interconnected over vast geographical areas. That means creating larger and more complex grids. In these interconnected systems, frequency of each subsystem must be controlled. So this is to ensure that all the areas they operate at the same frequency. That means load frequency control is essential in coordinating this, especially when power is transferred in between the different regions. When power is transferred in between the different regions, so load frequency makes the essential component to coordinate all these things. So which may create more complex parameters into simple parameters, and which makes the system performance to be smoother. So if the frequency control is not properly maintained in the interconnected system, then one area's disturbance could propagate to the other areas. That means which may leads to the widespread issues. Next parameter which mostly influence the load frequency control is here automatic generation control. What is this AGC? So automatic generation control means here load frequency control is a key component for the automatic generation control, that is AGC, which makes or ensures that the power output from generating unit is going to be adjusted in real time. So this is to maintain the desired frequency and AGC may operates in basically two modes, that is primary and secondary control. So load frequency control primarily takes care of secondary control, that is by compensating for sustained frequency deviations and keeping the balance over the time. So this is may happens with automatic generation control approach. Next case is about preventing the equipment damage. When electrical and mechanical equipments are existing, that may include the turbines, generators, and transformers, which are designed here to operate at specific frequencies. That means they may operate at the suitable frequency ranges. So significant deviations from the nominal frequency range can causes wear and tear or even damage to these components. That means load frequency control helps in reducing the stress on the equipment. That way, by minimizing the frequency variations. So this is to be done by one of the parameters called prevent equipment damage. And one more parameter that is influencing the load frequency control here is quality of the power supply. So that means power quality. Here it is called as power quality or quality of the supply. Quality of the supply. So what it determines usually means which determines the fitness of electric power. Fitness of electric power supply. Power quality determines the fitness of electric power supply. Here, the quality of power supply means quality of voltage, quality of current, quality of frequency, everything it will be related. That gives the quality of the power supply. So, maintaining a stable frequency that ensures a consistent and a reliable power supply to the consumers. That means frequency deviations can affect the performance of sensitive equipments in industries and household applications. That means they may operate and plays a vital role for load frequency controls, which may ensure that quality of the power supply. When it is associated with the quality of the voltage, quality of the current, and quality of the frequency only, then it may achieve suitably. So preventing load shedding or blackouts is one of the parameter that will mostly influence the load frequency control for the power system network. That means large frequency deviations which can going to trigger the protective mechanisms in the grid network such as load shedding or even blackouts are going to be associated for LFC operation or load frequency control. So here load frequency control here introduced to minimize the chances of these events by keeping the frequency fluctuations. That means which may undergone under control and helping to maintain the system integrity. So that may be done by some obtaining with key benefits, that is maintaining the frequency stability within the acceptable limits and balances supply and demand in a real-time case, ensuring system equilibrium condition. That means which facilitates the coordination of interconnected power system networks. So this may be happens with the protecting the equipment from damage due to frequency case. So this can be done by maintaining the frequency under suitable limits. So such deviations may ensure that high quality of power supply is needed for the consumers. So it should protect from fluctuations or interruptions. Fluctuations or interruptions, we need to protect the loads. So basically all loads are operating at constant frequency and suitable voltage and current ratings. When there may be a fluctuations in the load operating ranges, then load may supposed to malfunction. The winding may got damage or operating speeds may changes. So these are the effects may be results from the unnecessary of these events from the fluctuating cases of the loads case. So due to this, complete load may got damaged, and we need to protect with the suitable compensation methodologies like utilizing some controllers and compensation methods, SVC devices, static compensating elements. Like that, we supposed to consider such type of devices to make the quality of the power supply. So, which prevents the load shedding or blackouts means this is due to the frequency imbalances cases. So here load frequency control is basically indispensable case in the modern power system network. This should ensure the reliable, efficient and stable operation of the electrical grids. So because of this only we can maintain the quality of the power supply under suitable load conditions. So which gives the constant frequency under voltage and current variable parameters. So this can be mostly affecting the system performance that may be connected to the grid case. So here this frequency control operation essentially in the power system network are happened because of so many reasons. This is maybe due to system stability. So power systems may operate at a nominal frequency like 50 Hz or 60 Hz. So deviations from this frequency may also happen, which may leads to the instability case, affecting the reliability of the entire grid case, and maintaining the frequency within the acceptable limits case, which may ensure that the system remains stable and which can respond to the changes in load generation. So likewise, one system stability is one of the factor which may affecting the power system to operate with various frequency ranges. It may be happened with a 50 Hz or it may be with a 60 Hz frequency range. So this frequency range is most suitable to operating in India at various locations. So here we should achieve the condition that balance between the supply and demand we require. So when frequency is a direct parameter for indicating of the balance between electric supply and demand, then if demand is going to be exceeds the supply, then frequency may goes to drop. That means if supply is going to be exceeding the demand, then frequency is going to be increases. So this effective frequency control helps to maintain the balance which may prevent the blackouts of the system under overload conditions. So this is one of the condition which will maintain the balance in between the supply and demand. So this may be treated as one of the direct indicator. So that may ready to meet the demand case. So when it is ready to meet the demand case, whenever even though the supply is going to be exceeds and there may be drop in frequency and any frequency variations like increase in frequencies, then it may be leads to control over the effective frequency ranges and balancing conditions. So all these parameters cumulatively affecting the balance between the supply and demand when the power system network is operating. So here one of the most important factors we need to consider under these conditions of operating load frequency control means that is equipment protection. So what is this equipment protection means? Many electrical devices and machineries, they are designed to operate within the specific frequency ranges. So here the significant deviations may also cause overheating and they may reduces the efficiency of the system or even it may damages the equipment. So which leads to frequency control to protect these assets. That means whatever the blocks which are interconnected to the main power system network. So these are to be protected with the equipment protection scheme. So when there are interconnected systems are there in interconnected grids, what happening means maintaining a common frequency is a big task. That means it is very big crucial situations for the synchronization of different regions. That means the synchronizations allows for the sharing of the resources and enhances the overall reliability of the power system network. So likewise, these are the two key important parameters which will functions for smooth operations of the power system network as a interconnected manner and equipment protected manner. So the some of the relay components and circuit breakers also to be connected inside the system operation to make over the system to be under smooth secure conditions. And also one more parameter impacting for the load frequency control operation is integration of the renewable energy. This also plays a key role in the power system network. That is the increasing penetration of the renewable energy sources. That means which can be intermittent. So here intermittent means like wind and solar. This intermittency is going to be considered. So which is adding the complexity to the frequency control operation. So here the effective management is supposed to be required to accommodate these fluctuations. That means which will ready to maintain the system reliability case for integration of renewable energy sources. And one more important parameter considered is economic efficiency. What is this economic efficiency means? Maintaining proper frequency control. So that can leads to the more efficient operations of the power plants. So here we discussed the thermal power systems operations. So like that we may operate with idle cases, nuclear cases, like DG cases. So many power system plants they may supposed to operate for the integration of these systems with operating economic efficiency to the power system network, which gives the smooth results to operate under the certain conditions and make the system over great conditions. So here it allows for the optimal generation dispatch, and it can ready to minimize the costs associated with the frequency regulation, and it makes the reserves case to be smoother. So like that in this summary, the frequency control playing a very vital role for making the stability, reliability and efficient for the power system network, entire power system network, which may ensure that they can respond effectively to the changes in the demand and the generation case. So likewise, load frequency control is a very good task that maintaining the power system to be under keep safe operating conditions. So here our power system network consists a number of synchronous generators. We have number of blocks, number of divisions, so which will be operating under different conditions at a different places. So here the main aspect or common thing is about synchronous generators. They connected in a system, that is that they maintain the synchronism. So when they are making synchronism with each other, then this means that the angular separation between the rotor of the generator remains constant. That means for making to be suitable understanding about these parameters of synchronism, we should refer so many parameters related to the power system case. So here likewise the frequency part of maintaining constancy is very much important in the entire power system network. So these are some of the references whichever I have been taken, and which gives the suitable results of the power system control operation with the various things. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.